So on this worksheet, I want you to focus in on this section right here, which are equations, and we're going to solve by factoring them. Factoring is a reverse distributed property. You end up with multiplication. And why do we want multiplication? Because when it's set equal to 0, you could use zero product property to split them and solve. On yesterday's notes, I asked you to underline or highlight 3 different words. It was factor, split, and solve. And we know all these different factoring methods. We have all these different factoring tools in our factoring toolbox, right? This one right here, we have a quadratic trinomial where the a value is 1. It is 1. So when we do have an a value of 1, you might be able to set this up and factor using this format. Only when the a value is 1. If it were a 5, you wouldn't be able to set this up. Why? Because x times x is not 5x squared. X times x is x squared. So when there's no number, you could put x right there, the parentheses, and you're good to go. And the process is you think what times what is the c value, which is negative 12, that if you combine together is the b value. And I always recommend to do a list, and whenever I make my list, I start with the number 1 or negative 1. Negative 1 times 12 will give me that c value of negative 12. Negative 2 times 6 will give me that c value of negative 12. Negative 3 times 4 will give me that c value of negative 12. And those are the only 3 possibilities. So the question is, which pair of numbers, when I combine, not multiply, when I combine, as in 12 take away 1, that's 11. That's not the b value. That's right. Negative 2 and 6, when I combine those, I get a positive 4, right? 6 take away 2 is positive 4. And I do have a 4 right there, but it's negative. So I have the right numbers right here. I just have the wrong signs. So all you got to do is change that to a positive, change that to a negative, and we're good to go. There's my answer, or not my answer, my factored form, x plus 2 times x minus 6. So once again, I have changed this quadratic trinomial into factored form, which is now something times something. And why do I want multiplication instead of the subtractions up here? Because now that I have something times something equals 0, might as well write that down, equals 0. Now that I have something times something equals 0, zero product property says that first something could be 0, and also that second something could be 0. And if you solve both of them, you'll get your 2 answers, x equals negative 2 and x equals positive 6. On the work that I posted, I did skip some steps. Like, for example, I skipped this step of subtracting 2. So I didn't show all my work because of the limited amount of space that I had. So that's why I wanted you guys to copy them down in your notebook so you could have all the space that you need. Anyways, what do you think of that? Cool? Obviously, there's other factoring methods. It's not just quadratic trinomials that have the a value of 1. The very first type of factoring was pulling out the GCF, if there's anything in common. And that will happen, like on number 20 right here. Let's say I wanted to factor something here. Obviously, you can't think what times what is a c value that if you combine together is a b value because you don't even have a c value. But you could recognize that there's something in common in both terms, and you could pull out that GCF. What is a GCF? X, right? What would be left over on the inside if you pull out an x?
4.
Well, what would be left over right here? If you pull out one of these x's, what would be left over? Just an x by itself. And then x times what would give you the negative 4x? The minus 4, the negative 4, right? Okay, so I have factored the x. Now, why the heck would I want that? I mean, this is a nice binomial here. It says something take away something equals 0. But I can't actually subtract it. But when I rewrite it in factored form, now I have something times something equals 0. So now I could use that zero product property. When I have something times something equals 0, I could take that first something, set it equal to 0, and I could take that second something and also set it equal to 0. That's what zero product property is. And then you solve both, right? But this one right here is already solved. That's just saying x equals 0, and that's your answer. Okay? The other one, you solve it, plus 4, you're going to get your answer x equals 4. So your 2 answers are 0 and 4. Any questions? And again, you have all these factoring tools that you're supposed to be comfortable with. You got to know which tool to use on which problem. Sometimes you might have to use more than one tool. For example, taking a look at this guy right here. Remember, you might have a perfect square term in the front, perfect square term in the back, and you could square root them, but this is not one of those cases, right? So that tool does not work. But what tool could I use? What factoring tool could I use? I could pull out the GCF of 5, right? So if I wanted to, I could pull out the GCF of 5. What would I have left on the inside? X squared minus 7 of those x's. What's the third term? Plus 12. There you go. And this is still equal to 0. But now on the inside, you have in blue a quadratic trinomial where your a value is now 1. So now you could apply that other tool, factoring tool of xx, thinking what times what is my c value, the 12, that if I combine together is my b value, the minus 7. And of course, we always make a list when we want to think of the multiples of 12. So 1 times 12, or whatever that c value is, 2 times 6, 3 times 4, and that's it. Those are all the possible multiplication problems that give you 12 besides changing signs. So if we do combine 12 and 1, that's 13. That b value is not 13. Don't go to the original. Go to the one that you already factored the 5 out of. 2 plus 6 is 8. That's not 8. 3 plus 4 is 7. That is 7, but it's negative 7. So I have the right numbers. I just have the wrong signs. So I want to change both of those to negatives. So I really have a x minus 3 times x minus 4. It really is equal to 0. Don't forget about the 5 that's out there that you already factored out. Yes, they're both negative. The negative 3 times the negative 4 ends up giving you a positive 12, and when you add them together, it does give you that negative 7. Maybe I didn't make that negative sign big enough. I'm sorry. That's a negative sign. Anyway, now that you have something times something equaling 0, each of those somethings could be 0, right? Now, when you say, well, 5 could be 0, we know that that's false. It doesn't work, right? But when you do x minus 3 could be 0, yeah, that could work. You could solve that. And x minus 4 could be 0, yeah, you could solve that, right? So let's solve those two. Plus 3, plus 3. Answer is x equals 3. Other one, plus 4, x equals 4. That's perfectly fine. That's a great way of solving. Let me just explain this problem a slightly different way. My first step on this problem was to factor out the GCF of 5. But in reality, that's just because I wanted you to practice factoring, because on any equation, you could do whatever you want to the equation as long as you do it to both sides to the entire equation. So you could have technically, I think you mentioned it, divide by 5, divide by 5, divide by 5, divide by 5, including that 0. And you'd end up with x squared minus 7x plus 12 equals 0. And you'd end up with the same two answers anyway, right? But the only reason I decided to pull out a 5 as a GCF was just so we could continue practicing pulling out that 5 right there. But you could have divided everything by 5 just to make it look easier right from the start. Anyway, I don't know. Should we do another? You want to pick one? 18? Sure. 18. That's a nice one. I like it because the a value is 1, which means I could jump right into this. I mean, I hope I could do this because sometimes they're not factorable. But yeah, on this, I think, this worksheet, I think all of them are factorable. So let's make a list of the multiples of the c value of positive 8 that combine together to give you the b value, negative 6. So let's make that list. 1 times 8, or 2 times 4. And you just said 2 and 4, right? So we know that 2 and 4, when I combine them, it gives me 6. But I want it to be a negative 6. So I have the right numbers. I just need to change the signs on those numbers. And that will be a minus 2 right there and a minus 4 over there. And it's still equal to 0. But now that it's in factored form, now that we have something times something equals 0, we could split them and solve each of those easy equations. So something times something equals 0. That first something could be 0, and the second something could be 0. Solving both of those, you're going to get your two answers. X equals positive 2, x equals positive 4. And I didn't show my work again, I'm sorry. Plus 2, plus 2, plus 4, plus 4. And this is all just practice on this section. But I want you to attempt the first part of the worksheet. Even though it doesn't say to do it on the homework, it's a good idea to practice it. And the first part of the worksheet is where I give you the answers and I ask you to work backwards to get to the quadratic equation. It's kind of weird. Now, so if I did give you the answer 2 and the answer 4, pretend you didn't know this. This answer, x equals 2, had to come from a binomial set equal to 0. So in other words, you could move that 2 back over. That way you'll see that it came from the binomial x minus 2 equals 0. Does that make sense? And then from there, same thing over here. You could have subtracted 4. That way you'd see the binomial that it came from, which is x minus 4, right? Which is right here, x minus 4 equals 0. And then each of those binomials being set equal to 0 came from not splitting, but putting them back together. It came from splitting these guys. Okay, you know what? Let's actually do, because that might be confusing, me working backwards from there. But let's take a look at number 1, for example. Let's check out those instructions. It says, write a quadratic equation in standard form with the given roots. We know from last week that the word roots, what does that mean? Answers, the zeros, the solutions, right? The x-intercepts. So when they say they give you these roots, what they're really saying is that they're giving you the answers of a quadratic equation, and they want you to find what the quadratic equation is. So I would put down here x equals 7 and x equals 2, and those are the answers, and I want to work backwards to get to the quadratic equation that gave us those answers. So thinking about it, where did the x equals 7 come from? It came from a binomial that was set equal to 0. What was that binomial? X minus 7 equals 0, right? I mean, if you were to subtract 7, you'd have x minus 7 equals 0. Where did the x equals 2 come from? Minus 2, minus 2. Where did it come from? X minus 2 equals 0, right? And now, at this point, these two binomials that are separate equal to 0 each, they came from this binomial and that binomial being multiplied together. So x minus 7 times x minus 2, and that set equal to 0. I'm working backwards. I hope you guys see what I'm doing, understand what I'm doing here. And now, to get to the actual quadratic equation, you need to simplify, you need to distribute. X times x is x squared. X times negative 2 is negative 2x. And then negative 7 times x is negative 7x. And then negative 7 times negative 2 is positive 14. And it's still equal to 0. And when we combine these middle terms, we'll get the negative 9x with the x squared in front, with the plus 14 as a c value equaling 0. And ladies and gentlemen, this right here is my quadratic equation in standard form that would produce the answers 7 and 2. So all I did was do the work backwards. I had the answers, and I went back to the binomials that were set equal to 0, and then I went back to the... All right, so, I mean, again, even though this first part wasn't part of your homework, it'd still be a good idea to practice it. Would anybody like to try any other one of the first part? 1 through 9. 8? 8 sounds good. So 8, man, I give you those two answers. You get the answer x equals 1/3. You also get the answer x equals 2. That 1/3, that answer 1/3, it came from a binomial that was set equal to 0. Now, you might not see it right off the bat, but you could use algebra to get rid of this 1/3 to make it 0. Like if you're thinking 1/3, if I don't want a fraction, I could technically multiply both sides by 3, giving me 3x equaling 1. Yay? And then I could make this 1 finally become 0 by subtracting it and subtracting it. So if I subtract 1 here and subtract 1 there, I will now have the binomial 3x minus 1 that's set equal to 0. And that's where the answer 1/3 came from. It came from the binomial 3x minus 1 set equal to 0. Are you with me? Yeah. Where did this answer come from? Subtract 2, subtract 2. Obviously it came from x minus 2 set equal to 0. So what we have here are our two binomials set equal to 0. So it's a little more clear if you put them in parentheses and put them back together set equal to 0. So going backwards, we're going to put them back together, 3x minus 1, x minus 2, and set that equal to 0. And now to get to the actual quadratic trinomial, you're going to have to distribute and combine like terms. So 3x times x, that's 3x squared. 3x times negative 2, that's negative 6x. And then negative 1 times x, that's another negative 1x. Negative 1 times negative 2 is a positive 2. And that's still set equal to 0. So your final quadratic trinomial equation will be, after combining the negative 6x with the negative 1x, you're going to get the negative 7x in the middle, the 3x squared in the front, the plus 2 at the end with the equal 0 on the right side. This is the quadratic trinomial equation that will produce the two answers 1/3 and 2. Pretty cool, huh? Kind of. Any other questions down here on the solving?
Can you do 22?
Of course, 22. So let's take a look at number 22. And again, the whole purpose of factoring is to get multiplication. The whole purpose of wanting multiplication is to have it equal 0. That way you could split them and solve. So I don't even have an equal 0 here. So let's first get it to be equal 0 by subtracting 9x. Subtracting 9x. And of course, you cannot subtract 10x squared, take away 9x. They're not like terms. So let's just rewrite it. You're going to have a 10x squared, take away 9x equaling 0. Now, what factoring tool could you use here? Do you have a quadratic trinomial where your a value is 1? No. Do you have perfect square term in the front, perfect square term in the back? No. What's the very first tool you're supposed to always try to use? In fact, the GCF, right? Factoring with the GCF. So what's in common that you could pull out from here and here? What's in common that I could pull out?
X.
Just an x. Yeah, the 10 and the 9 have nothing in common, but there's x's in both of them. The maximum amount of x's I could pull out of both is just one single x. When you pull that one single x out, what's going to be left over on the inside? 10x to the 1, right? Think about it. X times what gets you back to a 10x squared? X times 10x gets you back to a 10x squared. X times what gets you to a negative 9x? Negative 9. There you go. So we have factored, and it is equal to 0 now. It was equal to 0. It's still equal to 0. But why do we factor? Because now we have x times 10x minus 9 equals 0. You have something times something else equals 0. Zero product property says that when you have two things multiplied together, each of those things could be 0. So the x could be 0. And also the 10x minus 9, that could also be 0. Right? And let's solve both of them. Again, the three words I wanted you to remember from yesterday was factor, split, and then solve. So we need to solve each of these. But the one on the left is already solved. It says x equals 0, and that's an answer. The one on the right, that's where you have to add 9. Add 9. It's going to get a little ugly. 10x equals 9. Final step would be to divide by 10. Divide by 10. Get your final answer. X equals 9/10. So those are your two answers. X equals 0 and x equals 9/10. So yes, there will be questions like this on the test, on the next test. Any other problems you'd like to see, or do you want time to practice? Time to practice. Okay. Well, if you have any questions, let me know.